Hi everyone, my name is Tia, and in this video I will be teaching you how to evaluate limits using function dominance. This is hands down one of my favorite techniques because of how simple and logic oriented it is. But even though it's so simple, it's such a powerful technique that makes a lot of work really easy. Consider the following problem. We have the limit as x goes to infinity, x squared plus 3x minus 4 in the denominator, and natural log of x in the numerator. Veterans to the calc game may recognize this as a L'Hopital's rule problem. However, we can use a basic technique called function dominance to solve this limit. Function dominance essentially involves comparing the growth rate of the numerator function and the denominator function. So the numerator function is a natural log function, and it starts off growing a little bit fast, but then it starts evening out and starts growing a little bit slowly. The denominator is a quadratic function, which starts off a little bit slowly, but then it speeds up. So as x approaches infinity, we can say that the denominator function grows faster than the numerator function. So there is this discrepancy between the numerator and the denominator. The denominator is getting larger and the numerator is lagging behind a bit. As a basic property of fractions, we know that when the denominator is larger than the numerator, the entire fraction value is tiny. And since we're looking at this from a lens of a limit, we can say that it's only getting tinier and tinier. And if something is getting smaller and smaller, we can say that it approaches 0. You can only use function dominance if the limit is as x is approaching infinity or negative infinity. Let's go over the order of dominance. So this is basically a list of types of functions from fastest growing to slowest growing, which will help you decide which function is more dominant. The fastest growing function is x to the x. In second place, we have the factorial, so that is x followed by an exclamation sign. In third place, we have the exponential function, so that is any number raised to the x power. In fourth place, we have the polynomial. An example of that is x squared plus 3x plus 4, and a polynomial with a higher degree has more dominance. In fifth place, we have the radical, so that's any variable that has any sort of root on it. In sixth place, we have logs, so an example of this is natural log of x. In seventh place, we have trig, so an example of that is sine of x. Trig functions take last place because they oscillate. I recommend you take a screenshot at this point because it'll help you out with the first few problems, but then eventually this all becomes your second nature. Let's move on and do some practice. So we have the limit as x goes to infinity, cosine of 2x over natural log of x. So here we have a trig function in the numerator and a log function in the denominator. From the order of dominance, we know that the log function increases quicker than the trig function, so we know that the denominator is the dominant part of the function. So the denominator is getting larger and larger while the numerator is lagging behind, so we know that the entire function value is getting smaller and smaller and approaching 0. The next problem is the limit as x approaches infinity, x squared plus 2x plus 1 over x to the 7 plus 3. There is a polynomial in the numerator and a polynomial in the denominator, so the highest degree takes dominance. So the degree of the numerator is 2 and the degree of the denominator is 7, so the denominator is the dominant part of the function. So the denominator is getting larger and larger while the numerator is lagging behind, so we know that the value of this limit is 0. Another important technique to recall at this point is horizontal asymptote. Since this is a rational function, The rule is that if the degree of the denominator is greater than the degree of the numerator, the horizontal asymptote is 0. Therefore, the limit is 0. So we just confirmed that the concept that we were applying does check out. All right, now let's move on to our final problem. We have the limit as x goes to infinity, e to the x over x to the 6th. We have an exponential function in the numerator, and we have a polynomial function in the denominator. According to our order of dominance, we can identify that the numerator is the dominant part of the function. This means that the numerator is getting larger and larger while the denominator is lagging behind. So the overall value is becoming larger and larger. So this value is getting larger and larger with no limit in sight. So you can say that the limit as x approaches infinity of this function is infinity. That's it for this video. Thank you so much for watching. If you have any questions, please leave them in the comments and I will get to them as soon as I can. If you have any topic requests, feel free to leave those in the comments.